Okay, so what we're going over in part 3 here is the description. We're going to talk about that. What we talked about in part 1 was we figured out what the equation was and the slope and y-intercept. And what we did in part 2 was we did the table of values, but we had to take also the equation section of this sheet, which has all these equations in different formats. And I showed you how we could make the equations set equal to y. This one's already set equal to y, whereas this one is not. Okay, and this is sort of a review here. Linear sorting, part 3. I went over in part 1, we learned the equation y equals mx plus b. Our equation that we are working with is y equals negative 1/2 x plus 3, where b is the y-intercept, so in this case that's 3, and m is the slope, so in this case negative 1/2 is our slope. Alright, in part 3, let's look at that sheet right here. It's telling us that graph A fits the description number 34. My son is playing a game in the background. And the description number 34 says this line represented by this graph is perpendicular to graphs F and G. Okay. So when we're talking about perpendicular or parallel lines, that is a whole new thing. When lines are perpendicular to each other, the slope of one will be the negative inverse of the other. So, for example, okay, so if the slope were to equal 2, the negative inverse of that slope, let's see if I can type that in. Negative inverse of 2 equals 1/2, and then you make it negative. It's negative 1/2, because 2, remember, is 2 over 1. So the negative inverse of slope 2 is negative 1/2. So anytime we have a line with a slope of 2 and then another line with a slope of negative 1/2, those lines are perpendicular. That's what that means. And then I have down here, when lines are parallel, the slopes will equal. That's pretty simple. If the slope equals 2 of one line and the slope equals 2 of another line, those lines are parallel to each other. They do have to have different y-intercepts, however, to be different lines. Okay. So when we look at graphs F and G, which we don't have slopes for because we haven't calculated those yet, let's look at those. F and G look very similar. And so what the claim is that A is perpendicular to those lines. When perpendicular, what that means, if you don't know what that means, is this. These lines are perpendicular. As long as they form a right angle on both sides, well, they have to be, then these lines are perpendicular. Parallel lines, of course, never cross because they're going along forever this way, or this way, or this way. These are parallel lines. And the same thing for perpendicular. You can be perpendicular this way. You can be perpendicular this way, as long as you're forming a right angle. What we're going to do is we have to look at F. But it's rise over run. So the rise goes first. 1, 2. Let me make that one. Make sure it's right. Yeah. Positive up 2 to the right 1. So let's start down here. Up 2 over 1, up 2 over 1. So rise 2, run 1, rise 2, run 1. So the slope of f is the slope of graph f equals, so you have the rise over the run. So the rise over the run is just what we said it was 2 seconds ago, which was up 2 to the right 1. So that's positive 2, positive 1. Up 2 to the right 1. So that means the slope equals 2. The slope of our line here is negative 1/2. So the question we ask ourselves is negative 1/2 the negative inverse of 2 of 2? Well, it looks like the inverse, the negative inverse to me, because the inverse of 2 over 1 is 1/2, and this is negative. So slope f must be slope of graph f. That means the line on graph f has to be perpendicular to the line on our graph A that we are looking at, or that we have been working with in each of these videos. So this is graph A. Graph A is perpendicular, and this is a symbol for perpendicular to graph F, meaning the line on F. Yeah. All right. Now, if we have graph G, I believe was the other one, right? Let's look at that slope. We've got rise 2, run 1, rise 2, run 1. It's the same slope. So we've learned a couple of things. Okay, so the slope of G is 2 over 1, and the slope of F is 2 over 1. So these lines are parallel, and those both lines are perpendicular to line A. Okay. Let's look at some other descriptions. If we have, this graph has a negative slope and a negative y-intercept. Well, in this description, you're going to look for a picture that has a negative slope, which, as you should remember, it'll be any graph whose line is going down like a ski slope. This is a positive because that's going up from left to right. This is up from left to right. That's positive slope. Up from left to right, positive slope. This is also a positive slope. So none of those fit the description we just read. This, however, is a negative slope. This is also a negative slope. Here's another negative slope. So we have E, C, D, and A are negative slope. B is positive. So it could be A, C, D, or E, but not F. A, C, D, or E. Well, we narrowed it down to that. So we were just reading description number 33. This graph has a negative slope and a negative y-intercept. So what that means is the line will have to cross the y-axis on the bottom side of the graph, or underneath the x-axis, on the negative part of the y. Okay, so these all have positive slopes, so they are not our graph. This has a negative slope, and the y-axis is here. The line crosses the y-axis here, which is a positive 2. So it's not that line. This line has a positive slope. This has a negative slope. The line crosses the y-axis at point 1, 2, 3. So that's a positive y-intercept. So it's not that graph. This line is a negative slope, and it crosses It crosses the y-axis at negative 1, 2, 3. So that is a negative y-intercept and a negative slope. Now let's make sure the rest, this is a positive slope, this is a negative slope, and it has a positive y-intercept because the y-intercept is 1, 2, 3. That's positive 3. So this graph D fits the description of number 33. That's what we have to do on how do you put the description to the right graph. You have to read it and see how each graph fits. A graph with the steepest negative slope, well, let's take a look at our graphs. A negative slope is downhill from left to right, so all these are positive. This one here is negative, that's pretty steep. That's pretty steep, but that still looks steeper. That's not as steep. That's definitely not steep. So I would say E has the steepest negative slope. And you can check that if you look at the slopes themselves. This one is up 3 to the left 1. So it's rise 3, run negative 1. Rise 3, 1, negative 1. There's 3 over negative 1. This slope, 3, 1, 2, 3 over a little more than 1. So it's not as steep. This slope is definitely not steep because you're going up 1 and over 2. Okay. Now let's look at a description. I'm just picking out descriptions for fun here. The line represented by this graph is parallel to graph D. Okay, if we were to try to figure that out, you have to know the slope of D, which is, I'm looking for parallel lines. The slope of D is up 1, 2 over 1. So positive 2, negative 1. So it's negative 1, which is negative 2. The slope here is negative 2, which is correct. It's a downward, so it should be a negative slope. So we have to look for another line who has the same slope of negative 2. As parallel lines will have the same slope. So let's look at this one. Up 2, negative 1. Up 2, negative 1. So, and it looks that way. These are both parallel. So these are parallel because they have equal slopes. Is there any others like that? This is up 3 over, this is up 1. What are other negative slopes here? We don't have any other negative slopes. Okay, so these are parallel. C and D are parallel.